All right, welcome to a section where we're going to be talking about absolute value. Everything will be absolute values. We'll be looking at solving the equations, we'll look at solving inequalities, we'll be looking at graphing, looking at, well, what are absolute values? Anything you can think of for absolute value right now in college algebra, that's what we're doing here. So let's do a really quick recap on the definition of an absolute value. The official definition, as you can look in your book, f of x, the function f of x equals absolute value of x, which equals x if x is greater than or equal to 0, negative x if x is less than 0. Okay, basically what this is saying is that the outcome of an absolute value is always non-negative. Notice I was careful to say non-negative and not positive because the outcome could be 0, which is technically not a positive number, but it's not negative either, so it's always non-negative. And you might be thinking, but Ms. Schofield, I see a negative x right here. How does the absolute value equal a negative x? Well, remember, no, look a little closer to the right there. It says if x is less than 0. So if your x is already negative, then the absolute value is the negation of that negative. And the two negatives cancel out, give you a positive. Right. So a couple of quick examples. Let's do a little writing here. Just real quick reminder, if you see something like absolute value of 2, the answer is 2. If you see absolute value of 0, answer is 0. If you see absolute value of negative 3, and here's where that negative x comes in, negative 3 is less than 0, so the result is the negation of that negative 3, which gives you 3. And the reason why it's always non-negative is because absolute value is essentially talking about distance from 0 on a number line. If you're doing the absolute value of 2, well, 2 is 2 units from 0 on the number line. If you're doing absolute value of 0, well, 0 is 0 units away from itself. And if you're doing absolute value of negative 3, negative 3 is 3 units from 0 on the number line. So the absolute value is telling you how many units you're dealing with from 0. Now, we've already touched a little bit on absolute value function in previous lessons. We learned that if we graph absolute value of x, we end up with this lovely V shape because it's basically f of x equals x with the absolute value thrown in. Like if you take 0, plug it in, absolute value of 0 is 0. If you take 1 and plug it in, absolute value of 1 is 1. If you take negative 1, absolute value is 1. 2, absolute value is 2. Negative 2, absolute value is 2. And you'll see that when you graph it, you get this lovely V shape. And you start plotting those points. So often absolute value graphs have a V involved. Well, really that comes from f of x equals x. If you were to graph f of x equals x, let me do it in a different color, but I'll do it on the same grid. No, that's probably not dark enough. Let me do it in a darker blue or something, or maybe purple. If you're doing f of x equals x, well, that would be this line right here. That'd be f of x equals x. But then since you're doing the absolute value of x, well, the part that starts at 0, 0 and goes through 1, 1, 2, 2, all of that already has positive outcomes, positive y's. And so that part stays the same. But the part to the left of 0, 0 has negative outcomes. Your y values are all negative there. So to apply the absolute value, you want those outcomes, those y's, to be positive. So what it does is it takes this chunk of the graph and it reflects across the x-axis and puts it up here. And that's why you get that V shape. You're taking anything that's below the y-axis, reflecting it across just that piece across the x-axis, and getting it above the x-axis so that all of the y's, all of what it equals, would be non-negative. So that's what's happening with these absolute values. Okay, so on to graphing absolute values. If you're given a function and told to graph its absolute value, keep in mind that all the outcomes must be non-negative. So all the y values have to be non-negative. To graph, anything that's on or above the x-axis, you can leave it alone. But take anything that's below the x-axis and reflect across the x-axis. And now everything will have non-negative y values. Notice that the domain remains the same while the range changes. I'll just quick jog back to the previous site. F of x equals x, the domain was negative infinity to infinity. We were plugging in any x, any real x we wanted. And then the range, we were getting all kinds of values back for y, and the range was negative infinity to infinity. But as soon as you did the absolute value of that, as soon as you went there, the absolute value, the domain was still negative infinity to infinity, because there's no limits on what you can plug in for x, but the range then was 0 to infinity. Because this part that had the negative y's from f of x equals x had gotten reflected up. So now the y values started at 0 and shot up to positive infinity. So domain stayed the same, range changed. All right, so let's take a look at an example or two. Let's first graph f of x in black. Let's say we have an f of x that's a kind of quirky shape like this one. Let's see here. Let's say you have an f of x that does this, and then shoots here, and then keeps shooting through there. Just plotting a couple of points to work with here. Okay, and let's say you're asked to then graph. I'm trying to find colors that stand out but they're still visible, and that's kind of hard to do. I guess I'll scream at you with red. I say scream at you because to me, like, putting it in red is like I'm shouting fire, fire or something. But anyways, let's do the absolute value in red. Well, this part that's above the x-axis already gets to stay here. It's already not, the y's are already non-negative. But the part that's below the x-axis has to reflect across the x-axis. So this point that's 1, 2, 3 units down now has to be 1, 2, 3 units up. This point that's 1 unit down now has to be 1 unit up. And this point that's 2 units down now has to be 2 units up. And this point connected to that point down here, so this point has to connect to that point up there. These two have to connect, these two have to connect. So in red, you now see the absolute value of that function. All of these ordered pairs, anything ordered pair you pick on this red graph, will have some kind of y value that's non-negative, 0 or higher. So the range, the domain's still the same. The domain went from -1 to infinity, and the range originally went from -3 to infinity. Well, now it's changed. Let's see, let me do the ink color in black. So f of x, the domain had gone -1 to infinity. The range had gone -3 to infinity. But as soon as we did that absolute value application, domain still went -1 to infinity. That's the x's. But the range, the y's changed now to be 0 to infinity. So just something to be aware of. Okay, let's see, what else do we want to do another example of that? Probably wouldn't hurt because the next slide gets into properties. So let's see here. maybe do one more example of graphing with the absolute value. Let's say, let's go back to black here. Let's say you're asked to graph f of x equals, let's see, what do we want to graph? F of x equals, let's do x cubed minus 4. Let's do something like that. So you're taking your x cubed graph and you're shifting it down 4. So let's see here. That's just normal f of x. Again, we're not doing absolute value just yet. So you're shifting it down 4. So if you plugged in 0, your y would actually be -4 now. If you plugged in 1, you'd get -3. If you plugged in 2, you'd get 4. If you plugged in -1, you'd get -5. -2, you get -12. Okay, so let me plot those. Oh, I might run out of room. 12 is way down on the bottom of my screen, but not visible to you because I have to cut the screen a little bit to do the recording. But you still get the idea. Okay. And again, a horrendous drawing, but this is the best I can do with this tablet. Anyways, so you see that. And then let's say we want to change it up and we want to say, all right, let's take that problem and let's do absolute value of f of x. Well, this part on up gets to stay. It stays where it is. But this 1, -3 has to reflect up. This 0, -4 has to reflect up. This -1, -5 has to reflect up. And the -2, -12 has to reflect up. So that's going to be at the very tippy top here. So all of that stuff reflects up, but then this part that's already above the x-axis gets to stay there. So the absolute value looks really interesting. It's kind of fun. All right, let's put it in a calculator. Let's put that exact problem into the calculator. Okay, let's go to y equals and let's put x cubed minus 4 in. So x and then this little caret symbol cubed minus 4. And then you hit graph. There you go. That's what we originally had in black on this. And then let's go back to y equals. And let's go ahead and do the absolute value. So let's go to math, number 1 is absolute value, ABS. And let's put in y1 so that it does the absolute value of that function. So go to vars, yvars function, y1. Oops, I'm trying to do a parenthesis there, sorry. Oh my goodness. Oh my gosh, let me do that again. Sorry. I was trying to use my keyboard. I probably should just use the calculator. All right, so absolute value, then vars, yvars, function y1, and then close the parentheses. And then let's do that one a little thicker. Okay, so oh, I'm hitting delete, not enter. Oops, there we go. No wonder I'm having trouble. Okay, so hit graph, and there you see it. You had your y1 here was thin, and then y2 is the thick. Y2 is what our red is supposed to be. So you can use your calculator and do the absolute value functions as well. Okay, back to the slideshow. Now let's have a little bit of fun talking about properties of absolute value. You might find these properties useful when you start solving equations or when you are even just trying to graph some kind of crazy absolute value. One of the first properties of absolute value says that if you are, oh my goodness, sorry about that. Let me get it on the pen so I can write. Make sure it's on black. There we go. Absolute value of a product is equal to the product of absolute values. So absolute value of AB equals absolute value of A times absolute value of B. So with numbers, if you have absolute value of 3 times 2, or absolute value of 6, which is 6, that's the same thing as doing absolute value of 3 times absolute value of 2, or 3 times 2, which is 6. So property that'll work for all your absolute values. You can do that. And you might find this helpful when you're working with absolute values that have slightly more complicated things inside of them. Like let's say you have absolute value of 3x plus 12. Well, you can factor out a 3 from 3x plus 12. And you might find it handy to know that you can break this up into absolute value of 3 times absolute value of x plus 4, or 3 times the absolute value of x plus 4. So down the road, you might find those kind of manipulations helpful. All right, now the second property, absolute value of a quotient is equal to the quotient of absolute values. So if you have the absolute value of A over B, that's equal to absolute value of A over absolute value of B. And what I must write is that B can't be 0. I know it feels like it's obvious, but that has to be stated. Your bottom number can't be 0 because then you have an undefined fraction. But hey, if you've got if you've got the absolute value of 7 over 11, you're allowed to break that up into absolute value of 7 over absolute value of 11. Or vice versa, you can combine the one on the right and make the one on the left if you want to. Absolute value of a number is equal to the absolute value of its opposites. Okay, this one's saying absolute value of A is equal to the absolute value of negative A. So in other words, if you have like the absolute value of 5, which is 5, that's equal to the absolute value of negative 5, which is also 5. And then the triangle inequality, you use this one a lot if you go on to calculus. So as you're going to stick around for trig and pre-calc and then calculus, keep this triangle inequality in mind. I felt like I used it all the time once I was, in my upper level math classes and also even in graduate school if anybody's going on. All right, the sum of the absolute values of two numbers is greater than or equal to the absolute value of their sum. Absolute value of A plus absolute value of B is greater than or equal to absolute value of A plus B. Notice it's greater than or equal to and not just equal to. That's called the triangle inequality. So it's not like multiplication where you can just say they're equal. It's actually, when they're broken apart, they're either greater than or equal to. Let's say you have the absolute value of 7 plus the absolute value of 13. On the other side, you have the absolute value of 7 plus 13. Well, 7 plus 13 here is 20, and absolute value of 20 here is 20. So here's a case where they're equal. But if you're doing negatives, let's say you have absolute value of negative 8 plus the absolute value of 20. That'll be 8 plus 20, which is 28. But on the other side, let's say you have the absolute value of negative 8 plus 20. That's the absolute value of 12, which is 12. So this was a greater than situation. So it's going to be either greater than or equal to. That's called the triangle inequality. All right, now let's get into the real fun. We looked at just the basics of what absolute values are and how to graph and some of the properties. Now let's dive into the fun of solving equations and inequalities. Starting with equations. If you have the absolute value of some expression and it equals a positive number, you have to consider that what's inside of the absolute value can be positive or negative. It's just that the final answer when you're all done has to be positive. So you have to set up a compound equation. You have to set up the scenario where this ax plus b equals whatever k is, which will be non-negative, or what if ax plus b in here is negative? You got to set up both scenarios. And then you got to make sure you check your solutions using the original equation. Then down here, you got the graphical method. You can use the intersection of graphs method and use your points of intersection to help you see what's happening. We'll do that with the calculator on our when we do our problem that we're going to do. All right. Let's say you have something like absolute value of 2x plus 4 equals 8. Okay, as long as this k is positive, then you can set up that compound equation and solve this. Now notice that this over here has to be positive, or non-negative, I should say. Not, it could be 0, because this absolute value here cannot equal a negative. If you see a negative over here, then you can just stop right there and go, oh, there is no solution to this, because you can't have an absolute value equal to a negative. Just saying. So here we go. We got to set up two scenarios. Either the 2x plus 4 and inside the sign equals the 8, or what's inside the sign equals negative 8. And of course, after we apply the absolute values, then you get your positive 8. So you got to make sure you solve for both scenarios. Okay, if 2x plus 4 equals 8, 2x equals 4, x equals 2. And if 2x plus 4 equals negative 8, 2x equals negative 12, x equals negative 6. So we'll check. We plug in 2 to the original. Let's go back to the original using the absolute values to check. We've got absolute value of 4 plus 4, which is the absolute value of 8, and that does indeed equal 8. And then you got absolute value of 2 times negative 6 plus 4 is the absolute value of negative 12 plus 4, which is the absolute value of negative 8, and that does indeed equal 8. So both check out. Both of them are solutions. So your solution set includes negative 6 and 2. Okay. Now, if you have something a little fancier, a little more to it, like let's say you have 5 absolute value of x plus 3, and then minus 2 equals 18. Before you go to solve it, make sure you get the absolute value by itself. So make sure you go ahead and add 2 to both sides. Divide by 5 on both sides. Then set up your compound equation, because our technique we're using depends on you having an absolute value equals a non-negative number. So then you can set up x plus 3 equals 4, or x plus 3 equals negative 4. X equals 1, or x equals negative 7. So your two solutions are negative 7 and 1. That's your solution set. And of course, check. Go back to the original problem to plug in your negative 7. And then basically follow order of operations from there. Okay, first number checks out. And then do the same thing with your 1. Go back. It's like 2 checks because there's 2 answers. So go back and plug in the 1. Yay! Okay, so they check out. Well, let's go stick that in a calculator real quick here. Let's put the first one in the calculator just to see how to deal with it. All right, so we're going to put in the absolute value of 2x plus 4. So go to math, go to number, and number 1 is absolute value. 2x plus 4, close parentheses. And then I'm going to go ahead and do that intersection of graphs method. So I'm going to go ahead and put 8 in for y2, and then hit graph. So left side went in for y1, right side went in for y2. And in the graph, I can see the V shape for the absolute value of 2x plus 4. I can see the line for y equals 8. And wherever these intersections occur, those x values are my solutions. So I'm going to go to second trace to calculate intersection. Number 5, intersect. Let's get over close to that first intersection, otherwise might not give me the one I want right now. So enter, enter, enter. And then that first intersection, you're saying x equals -6. And that's exactly one of the solutions I got. And then let's do it again. Second trace to calculate intersection. Number 5. Let's move over towards the other intersection. You need to be kind of close to it so that the calculator knows to look at that one. You don't have to be right on it, but just close to it. Enter, 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 and voila, x equals 2. And that's what I got for the other solution, was 2. So your calculators can be used here just like they're used for other equations, like the linear equations and things. Okay, what's next? Absolute value inequalities. So just like you can do equations, you can also do inequalities. The inequalities look kind of like the equations, but you got like a greater than or greater than equal to or less than equal to. If you see greater than or greater than equal to, you're going to set up compound inequality with an OR. First one has greater than, second one has less than. If you see less than, you're basically setting up an AND compound inequality. The less than's here on the right, and then greater than over here. Notice you got to negate the K when you set up the opposite inequality there on both situations. So solve those and that'll help you find your intervals for your inequality, or you can also look at the graph and get your results that way. Okay, so let's take a look at an inequality problem, do it analytically. Let's see, try to pick a fun one. Just kind of looking in the book. I'll do that one. All right, let's say we have absolute value of 2x plus 1, then close absolute value, plus 3 is less than or equal to 5. So we have that. Let's go ahead and get the absolute value by itself. So let's go ahead and subtract 3 from both sides. So that's less than or equal to 2. And then since we have less than or equal to, we have absolute value less than or equal to 2, we can set this up. The 2x plus 1 less than or equal to that positive 2, but also 2x plus 1 greater than or equal to negative 2. And this gives me the intersection compound inequality, the one that you would use the word and with. So 3-part inequality. Subtract 1 from all 3 parts. Divide by 2 on all 3 parts. So your x value falls somewhere from -3/2 to 1/2. And since it's less than equal to here and here, we've got to use brackets. Now, if the same problem had been greater than 5, I would have still subtracted 3 from both sides. And then in that case, it would be 2x plus 1 is greater than 2, or 2x plus 1 is less than negative 2. So then you solve that compound inequality. It's a union kind of question with the word or. So in this one, you have 2 separate intervals that you're going to have to join with the union symbol. And then in this one, I had just used a greater than to begin with. So I got to use parentheses around this 1/2 and around this -3/2. So I've got negative infinity, which always has a parenthesis, comma -3/2, parenthesis, union, parenthesis 1/2, comma, positive infinity, which always has parenthesis. So this is saying that anything below -3/2 and anything above 1/2 can get plugged in for x and make this work. Okay, let's stick that one in a calculator too. I love seeing the pictures in the calculator to see how this works. All right, so let's go back to y equals. Let's clear y1. Let's clear y2. Let's put our new stuff in. Left side, okay, absolute value of 2x plus 1 and then plus 3. Close your parentheses after 2x plus 1 because that plus 3 is not part of the absolute value. And then for y2, put in the, oops, sorry, put in the 5. Okay, hit graph. There we have it. Compute your intersections. So second trace, number 5. I'll move over closer to the left intersection. Enter, enter. That one's giving me -1.5, which doesn't surprise me because -3/2 is -1.5. And there and there. And then the other intersections, do that. Let's move over closer to that point of intersection. Enter, enter, enter. And I get 0.5. Doesn't surprise me because that's positive 1/2. Okay, so the first question was less than or equal to. So in the first question, I'm looking at where is y1 less than or equal to y2? Where does y1 fall below y2? And that's in here. Then in the second one, I'm looking at where does y1 greater than y2? Where does y1 fall above y2? And that's this piece and this piece. So let me sketch that for a second. Oh, pen is red again. So I just chosen black. There we go. Okay, so the V shape is your y1. You got y1 is less than or equal to y2. And here you got y1 is greater than y2. Then that line, where's your y2? That's like y equals 5. This point you got x equals -3/2 or -1.5. This point you got x equals positive 1/2 or 0.5. Okay, let's change the colors. Let's change to maybe green. Okay, so for y1 less than y2, right here, I'm looking at where is y1 falling below y2. And I see that happening right here. So from -3/2 to 1/2, I see where y1 falls below y2. And that's this interval, -3/2 to 1/2. And I use the brackets to include because it was less than or equals to. The bracket says that it's okay to be equals to those two numbers. Let's switch colors. Let's go, that was green. Let's go to red, Christmassy. All right, y1 greater than y2. We're looking at where is y1 above y2. Well, right here, I see y1 above y2, and that extends, to infinity. And right here, I see y1 above y2, that extends to infinity. So from out here, -infinity to here, and then from here to out here at infinity. So from -infinity to -3/2, and from 1/2 out to infinity, y1 is above y2. y1's greater than y2. And since we're talking just greater than, we got to use parentheses. And we use the little union symbol to say make sure you include it. So your solutions can be found either below -3/2 or above 1/2 on your x's. So there's a little bit about solving absolute value inequalities. Then one more little thing here. How about equations where there's more than one absolute value? Same kinds of principles. What's inside the absolute value can be positive or negative. So you have to account for both situations, even though the outcome after the absolute value is positive, not negative. So you take, if you have something like this with two absolute values, like absolute value equals absolute value, you take what's inside and what's inside, set them equal. That knocks out situations where they're both positive or where they're both negative. You take the inside of one and set it equal to the negation of the other, and that knocks out the situation where one's positive and one's negative. They're opposites. All right, for example, let's do one. Let's see here. Let's say we have something like, trying to find a fun one. Maybe we don't want too fun. That'll be all right. Absolute value of -2x plus 5 equals absolute value of x plus 3. Okay, so we take into account the scenario where they're both either the same or they're both negated by doing this. And then we take into account the scenario where one's the same and the other one's negated by doing this. Doesn't matter which one you negate, just negate one of them. All right, solve each scenario. All right, this one I'm going to add 2x to both sides, subtract 3 from both sides, then divide by 3 on both sides. This one, I'm going to distribute my negative on the right there. I'm going to go ahead and add x to both sides, subtract 5 from both sides, then either multiply or divide both sides by -1. And there's my answer for that one. Okay, so my solution set would be 2/3, 8. There's two solutions here. If I decided to check, which is always a good idea, especially with these kinds of problems, plug in the 2/3 into both sides, make sure it works out. Woohoo, that one worked out. Then go back, plug in the 8 to both sides, make sure that also works out. Woohoo! That worked out too. So there we go. So there's some info about absolute value functions and absolute value equations and absolute value inequalities. Hope you have fun. I really enjoy these, especially with all the V-shaped graphs. To me, they're a lot of fun. Have fun and then tune in again soon because we will be moving on to looking at functions and their operations, including compositions. I promise I'm signing